Good evening. In today's class, I am going to explain you some more problems given in previous JEE main examination in the chapter system of particles, especially on the topic moment of inertia. So, let us move on to the problems given. Previously, we have completed 85 problems already. So, let us begin with 86th question. 4 particles each of mass 1 kg are placed at the 4 corners of a square of side 2 meters. So, the mass of each particle is given as 1 kg and the side length of the square given is 2 meters. You are supposed to find the moment of inertia of the system about an axis perpendicular to the plane passing through one of its vertex. Vertex means one of its corners. So, here we have to find the moment of inertia of the system about an axis passing through the corner and perpendicular to the plane like this. So, here the formula we are going to use is I is equal to m1 r1 square plus m2 r2 square plus m3 r3 square so on, where m1, m2, m3 so on are the masses of the particles, r1, r2, r3 so on are their respective perpendicular distances from the axis of rotation. So, here this particle is on the axis, so its perpendicular distance is 0, hence moment of inertia of this particle with respect to that axis is 0. Moment of inertia of this particle about this becomes mass is 1 and this perpendicular distance is 2 meters, isn't it? So, 2 square plus moment of inertia of this about this is mr square, mass is 1, perpendicular distance between them is 2 meters once again 1 into 2 square plus for this mass is 1, perpendicular distance of this from this axis is nothing but the diagonal length, that is root 2 into side length is 2. So, here it is 2 root 2 whole square. So, this becomes 4 plus this is 8, 8 plus 8 it is 16 kg meter square. That is the correct answer for that problem. Move on to the next problem. Look here, I think we skipped one. Look into this, 2 identical solid spheres each of mass 2 kg and radius 10 centimeters are fixed at the end of a light rod. So, this is a light rod whose mass is negligibly small. Mass of each sphere is given as 2 kg and its radius of each sphere is given as 10 centimeter. If you convert that into meters, it is 0.1 meter. Separation between their centers, that is the length of the rod used, is 40 centimeters. You are supposed to find out the moment of inertia of the system about an axis perpendicular to the rod passing through its center. So, that is the axis is like this. So, this distance becomes 20 centimeters or 0.2. This distance is also 0.2 meters. Now, for this sphere, this axis is not passing through the center of mass. If we need to find moment of inertia of any object about any axis not passing through the center of mass, we have to think of parallel axis theorem, which says that I is equal to Ig plus mr square, where Ig is the moment of inertia of the object about an axis parallel to the given axis and r is the perpendicular distance between the two axes. So, I is equal to parallel axis theorem Ig plus mr square. Ig is moment of inertia of this sphere about an axis passing through the center of mass and r is the perpendicular distance between the two axes. So, here Ig for a sphere, because the two spheres are identical and their distances from the axis are also equal. So, we just multiply with 2, that gives the net moment of inertia of the system about the given axis. So, it is for a solid sphere, it is mentioned two identical solid spheres. For a solid sphere, moment of inertia about the central axis is 2 by 5 mr square plus mr square into 2. So, look here, 2 by 5, mass is given as 2 kg, r square 0.1 into 0.1, 10 power minus 2, plus mass is given as 2 kg, small r is 0.2 meters, distance between the two axes. So, 0.2 into 0.2 is 4 into 10 power minus 2 into 2. So, let us do the simplification part carefully. See here, from this I is equal to, I am bringing the 2 also to this side, 4 by 5, 2 into 10 power minus 2. We can take it as a common factor. Okay. So, 4 into 10 power minus 5, 2 into 10 power minus 2, we can take it as a common factor outside. So, here we are left with 1. No, let us see, I think I made a mistake here. So, here this is 2 by 5, m is 1 kg, 2 kg and r is 0.1, square is 10 power minus 2 plus 2, small r is 0.2, 0.2 into 0.2 is 4 into 10 to the power of minus 2. So, this is 2 into, you can take this 10 power minus 2 outside, 10 power minus 2, 4 by 5, it is 0.8 plus 2 4s are 8. So, this is I is equal to, see here, 2 into 10 to the power of minus 2 into 8 plus 0.8 is 8.8. This is 17.6 into 10 power minus 2 or 176 into 10 power minus 3 kg meter square. If you look at the question, he given that something into 10 power minus 3. So, that numerical value is 176. So, 176 into 10 power minus 3 kg meter square is the answer for that. Go for the next problem. Moment of inertia of a semicircular ring about an axis passing through the center. See, let this be a semicircular ring. Moment of inertia of this semicircular ring about an axis passing through the center and perpendicular to the plane of the ring, it is I is equal to just mr square. So, here it is given as 1 by x into mr square. On comparison, you will be getting x as 1. Such a simple problem it is. Okay. Now, move on to this one. A ring and a solid sphere rotating about an axis passing through their center have same radii of gyration. Radii of gyration are same. The axis of rotation is perpendicular to the plane of the ring. Ratio of radius of the ring to that of the sphere. Look here, axis of, in case of a ring, moment of inertia I1 is equal to mr square. If the axis passes through the center perpendicular to the plane, it is mentioned that the axis passes through their centers. So, I1 is mr square, from which we know for any object I is mk square. Just on comparison, radius of gyration of the ring is r. Let us take it as r1. If you take the radius of the ring as r1, k1 is equal to r1. Now, coming to the case of a solid sphere. In case of a solid sphere, moment of inertia is 2 by 5 m r2 square, because they have the same mass and radii are different, right. So, here whatever, even if they don't have the same mass, when we are interested in radius of gyration is independent of the mass, so nothing to do with mass here. So, I2 is equal to 2 by 5 m R2 square. So, here radius of gyration of the solid sphere about an axis passing through its center becomes square root of 2 by 5 R2. In the problem, it is mentioned that they have the same radius of gyration. They have the same radii of gyration. K1 is equal to K2 implies K1 is R1 and K2 is equal to square root of 2 by 5 R2. So, what is asked here? The ratio of radius of the ring R1 by R2, radius of the sphere, that is equal to 2 by 5 under root, but it is given as root of 2 by x. So, in place of x we have 5, that is the answer. Actually, if you are thorough with the formulae, you need not do all those things. For a ring about an axis through its center, radius of gyration is just r. For a solid sphere, it is equal to square root of 2 by 5 r2. If they are equal, r1 by r2 is equal to root of 2 by 5. That's it. Okay. Now, move on to the next problem. A solid sphere of mass 500 grams. Mass is given as 500 grams. If you convert that into kg, it is 0.5 kg. And its radius is 5 centimeters. So, radius is 5 centimeters, isn't it? So, here it is 5 into 10 to the power of minus 2 meters, rotated about one of its diameters, okay, with an angular velocity 10 radian per second. If the moment of inertia of the sphere about the tangent, moment of inertia of a solid sphere about any tangential axis is 2 by 5 mr square plus mr square, again from parallel axis theorem, that is equal to 7 by 5 mr square. So, moment of inertia of a solid sphere above tangential axis is 7 by 5 mr square. He mentioned in the problem, moment of inertia of the sphere about a tangent is x into 10 to the power of 2 times, x into 10 to the power of minus 2 times angular momentum about the diameter. Angular momentum is I omega. I is 2 by 5 mr square about the diameter omega. So, here it is mentioned that for a solid sphere about the tangential axis, moment of inertia, that is 7 by 5 mr square, it is equal to x into 10 power minus 2 times its angular momentum about the diameter. About the diameter, angular momentum is I omega, about the diameter I is equal to 2 by 5 mr square. So, from this, if you cancel these two, what do we get? 7 by 5 is equal to x into 10 power minus 2 into 2 by 5 and omega is given as a 10 radian per second. So, this 5 and 5 gets cancelled, x is equal to 7, this 10 power minus 2, if it comes this side, it becomes, anyway, 10 into 10 power minus 2 is 10 power minus 1, that if it comes to the other side, it becomes 10 divided by 2. So, it is 70 by 2, so it is 35. Okay. So, the value of x is equal to 35, that is the answer. So, here the key is moment of inertia about the tangential axis 7 by 5 mr square is x into 10 power minus 2 times its angular momentum about the diameter. So, about the diameter, moment of inertia is 2 by 5 mr square into omega, that is all. Go to the next problem. Look here, two disks of same mass and different radii are made up of different materials such that their thicknesses T1 is equal to 1 centimeter, thickness of the second disc is given as 0.5 centimeter respectively. The densities of the materials D1 is to D2. So, D1 is given as 3 units say and D2 is given as 5 units. The densities are in the ratio 3:5. Moment of inertia of these discs respectively about their diameters will be in the ratio x/6. For any disc, moment of inertia about the diameter becomes mr²/4. Both of them are discs, isn't it? So, about the diameter mr²/4. So, this is constant factor. The two discs have same mass. Mass is also constant, but no information is given about the radii here. So, here mass is equal to volume into density. Volume is equal to pi r²T into density. So, mass is equal to pi r²TD. So, here mass is constant, pi is constant. So, r² is inversely proportional to TD. R² is inversely proportional to TD. So, here what is asked? Moments of inertia of the discs about their diameters will be in the ratio. So, moment of inertia is directly proportional to r². As r² is inversely proportional to TD, I is inversely proportional to the product of T and D, which implies I1 by I2 is equal to T2 by T1 into D2 by D1. So, I1 by I2 is equal to, see here, T2 by T1. T2 is 0.5 and T1 is 1. D2 is 5 and D1 is 3. So, here 0.5 can be written as 1 by 2 into 5 by 3, or it is 5 by 6. The ratio is 5 by 6, but they gave it as x/6. They gave it as x/6. So, in place of x, we have 5. You are supposed to find the value of x in that problem. Okay. Now, 92. Moment of inertia of a disc of mass m, radius r about any of its diameters is mr²/4. Moment of inertia of this disc about an axis normal to the disc and passing through a point on its edge will be. Look here, it is given moment of inertia of this disc about the diameter, it is given as mr²/4. What is asked? Moment of inertia of this disc about an axis normal to the disc and passing through the point on its edge. Okay, look here. If moment of inertia of a disc about the diameter is mr²/4, about an axis passing through the center perpendicular to the plane will be mr²/2. Actually, we derive that, or we can from this we can find it out from using perpendicular axis theorem. So, here what is asked? Moment of inertia of this disc about an axis normal to the axis passing through the edge, tangential axis perpendicular to the plane. For a disc, it is I is equal to Ig plus mr², that is mr²/2 plus mr², that is 3/2 mr². So, here he mentioned it as x/2. In place of x, we have 3. So, you have to have the concept and also all those relations. You need not by heart, just you know about the natural axis, that is axis through the center perpendicular to the plane is mr². So, about a parallel axis, that is the tangential axis perpendicular to the plane becomes mr²/2 plus mr², it is 3/2 mr². Okay, move on to the next problem. ICM is the moment of inertia of a circular disk about an axis passing through the center and perpendicular to the plane. Just now we have seen moment of inertia of a disk about an axis passing through the center perpendicular to the plane is mr square by 2. IAB is the moment of inertia about an axis perpendicular to the plane, parallel to the axis through the center of mass given and at a distance 2/3 from the center, where r is the radius. So, that is given as IAB. Okay. The ratio of IAB and ICM we need to find out. Just here, that is, suppose if this is the disk, this is the moment of inertia about an axis passing through the center perpendicular to the plane. This is given as ICM, and another axis like this. This is another axis given IAB. This axis is also perpendicular to the plane, but it is at a perpendicular distance 2/3 r. So, here we can comfortably apply parallel axis theorem to find IAB. It is equal to IG plus mr square, where r is the perpendicular distance between these two axes. So, IAB is equal to IG. This is a disk about a central axis perpendicular to the plane, mr square by 2 plus m. Perpendicular distance between them is given as 2/3 r whole square, that is 4/9 r square. If you simplify this, mr square, you can take it as a common factor outside, 1/2 plus 4/9. So, take the LCM. We are writing IAB now. IAB is equal to mr square. LCM is 2 into 9. So, 9 plus 2 4s are 8, right. So, IAB is equal to, just I am writing separate, mr square by 2, 9 plus 8 is 17/9, right. So, here what is asked here? Look, IAB to ICM ratio. ICM is mr square by 2. So, IAB ICM ratio will be equal to IAB by ICM will be equal to 17/9, isn't it? Mr square by 2, mr square by 2 gets cancelled. So, but here he has given the ratio as x:9. We got it as 17:9, but he gave it as x:9. So, in place of x we have 17. Okay, just application of parallel axis theorem. Go to this problem. A solid sphere of mass 5 kg. Mass of the sphere is given as 5 kg here, and a disk of mass, sphere of mass 5 kg and disk of mass 4 kg have the same radii. R1 is equal to R2. Ratio of moments of inertia of the disk about the tangent in its plane. For a disk, about the diameter in its plane is mr square by 4. About the tangent in its plane becomes, from parallel axis theorem, mr square by 4 plus mr square, that is 5/4 mr square. So, here moment of inertia of the disk about a tangent in its plane. So, I1 is equal to 5/4 m1 r square, because it is given that they have the same radii, that is I1, and I2. Ratio of moments of inertia of the disk about the tangent in its plane to the moment of inertia of the sphere about the tangent. For a solid sphere, moment of inertia about the tangent, that is this Ig is equal to 2 by 5 mr square for a solid sphere. Perpendicular distance is r plus mr square. So, this becomes 7 by 5 mr square. So, it becomes 7 by 5 m2 r square, because masses are different, radii are equal. So, the ratio of moments of inertia. So, moments of inertia of the disk to the sphere. I1 by I2 is equal to 5 by 4 m1 by 7 by 5 m2. So, this is 5 by 4, m1 is 5 by 7 by 5, m2 is 4. m2 is 4. So, here what is asked in the problem? The ratio is given as x by 7. So, there is a small mistake in the problem. Let us correct that mistake. It is simple. So, here moment of inertia of the disk about the tangent in its plane is 5 by 4 mr square. So, 5 by 4 m1 r square. For a solid sphere, 7 by 5 m2 r square. So, here the ratio is x by 7. Okay. So, I1 by I2 is given as x by 7. So, x by 7 is equal to I1 by I2, that is 5 by 4 into m1, solid sphere. But here in this case it is taken, first one is taken as the disk. So, disk mass has to be taken as m1 and sphere mass should be taken as m2. That is the mistake we have done. So, m1 is 4. So, 5 by 4 m1 by 7 by 5 m2. So, this and this gets cancelled, this and this gets cancelled, x is equal to 5 by 7, x by 7 is equal to 5 by 7. So, x is equal to 5. That is the answer for that problem again. Is it all right? Moment of inertia of the disk about the tangential axis to moment of inertia of the solid sphere about the tangential axis ratio. So, 5 by 4 into mass of the disk by 7 by 5 into mass of the solid sphere. Okay, go to this problem. A solid sphere is rotating about an axis PQ. This is the axis of rotation. Radius of the sphere is given as 5 centimeters and its perpendicular distance from the axis, small r, is equal to 10 centimeters. Okay, then radius of gyration about PQ. Radius of gyration about PQ. So, here about this axis, let us take the moment of inertia as I is equal to Ig plus mr square. I is equal to mk square. Ig is equal to 2 by 5 mr square plus m into small r square. So, you can take that m as a common factor and cancel. So, k square is equal to 2 by 5 r square plus small r square. So, this is 2 by 5 and r square, it is given, everything is given in centimeters, even the value is given in centimeters. K is given in centimeters ultimately, so you need not convert. 2 by 5, r square is 5 square plus small r square is 10 square. So, here 2 into 5 plus 100. So, that is 110. K square is equal to 110, but k is equal to square root of 110, but it is given as root x So, it is x value is 110. So, here I is equal to Ig plus mr square. Move on to the next problem. A uniform solid cylinder with radius r, length L has moment of inertia I1 about the axis of the cylinder. For a solid cylinder, moment of inertia about the natural axis is just mr square by 2. A concentric solid cylinder of a radius r by 2 and length L by 2 is carved out of the original cylinder. So, from a solid cylinder, another portion of half the radius, half the length is carved, that is cut exactly the central portion and removed. You are supposed to find its moment of inertia is I2, moment of inertia is of the carved portion of the cylinder is I2. Both I1 and I2 are about the axis of the cylinder. What is the ratio? See here, even for I2, moment of inertia becomes m2 r2 square by 2. So, as you are asked to find the ratio, I1 by I2 is equal to m1 by m2 into r1 square by r2 square, because you are supposed to find I1 by I2. So, r1 square by r2 square. So, here mass of a cylinder, if both of them are made up of the same material, because a portion of it is carved out, so it has the same density. So, mass is proportional to volume, that is pi r square L. As pi is constant, mass is proportional to r square L. So, here in the second case, radius is halved. So, 1 by 2 whole square. Length is also halved. So, m2 is equal to 1 by 8 times m1. So, m1 by m2 is equal to 8. Now, because I1 by I2 is asked, r1 by r2, it is 2 whole square. So, 8 into 4, it is 32. So, ratio is 32:1 or 32. That is the answer. Okay. So, here it is directly proportional to m r square, mass proportional to volume. So, mass becomes 1/8 and r square 1 r by r becomes half. So, r square becomes 1 by 4. So, 1 by 32 times of the original value will be the moment of inertia of the removed part. So, I1 is to I2 ratio will be 32. Look into this problem. 4 identical discs each of mass m diameter are arranged in a small plane as shown. Moment of inertia of the system about the axis. See here, 4 identical spheres are arranged like this. Okay, they are identical spheres. Axis is like this. So, for these two, this axis is the diameter. You are asked to find the moment of inertia of the system about this axis. They are identical discs. For a disc about the diameter, it is m r square by 4 about the diameter. But here diameter is given as A. So, anyway, let us take it as R, and finally we substitute as diameter is A, R will be equal to A by 2. At the end we can substitute that. So, moment of inertia of these two discs mr square by 4 into 2 plus for these two discs, this becomes a tangential axis in its plane. For a disc about the tangential axis in its plane, moment of inertia is 5 by 4 mr square. There are two such discs, so 5 by 4 mr square into 2. So, let us take this and this gets cancelled too. So, here mr square by 2 can be taken as common factor outside, 1 plus 5. So, 6 by 2, that is 3 mr square. But here the answer is given in terms of A, where r is equal to a by 2. So, this is 3 m a by 2 whole square. So, this is 3 m a square by 4. See, m a square by 4 is there. In place of x, we have 3. So, answer for that is 3 here. Okay, move on to the next problem. Radius of gyration of a cylindrical rod about the axis of rotation perpendicular to its length passing through the center will be. So, perpendicular to its length, radius of gyration of a cylindrical rod about an axis of rotation perpendicular to its length and passing through the center. If this is a cylindrical rod, about the axis passing through the center perpendicular to its length, I is equal to ml square by 12. So, I is mk square is equal to ml square by 12. From this, k is equal to L by root 12, or it is L by 4 into 3 or L by 2 root 3. That is the radius of gyration formula. Here length is given as 10 root 3. So, 10 root 3 divided by 2 root 3, this and this gets cancelled. So, k is equal to 5 meters. Radius of gyration is 5. That is the answer. Move on to the next problem. Moment of inertia of a uniform thin rod about a perpendicular axis passing through one end. So, I1 is equal to ml square by 3. The same rod is bent into the form of a ring and its moment of inertia about the diameter. So, moment of inertia of a ring about its diameter, it is equal to mr square by 2. But here r is not given, radius of the ring is not given. That rod is bent into the form of a ring. So, L is equal to 2 pi r, because the length of the rod becomes equal to the circumference of the ring, because the same rod is bent into the form of a ring, from which r is equal to L by 2 pi. So, just I2 is equal to mr square by 2. So, m by 2, r square is L square by 2 pi whole square, L square by 4 pi square. So, I1 by I2. I1 by I2, ml square gets cancelled. So, 2 into 4 pi square by 3, right. So, this is equal to 8 pi square by 3, but he mentioned it as x pi square by 3. In place of x we have 8, so the answer is 8. Okay, x is equal to 8. And the last problem for today's class. A thin uniform bar of mass 6 kg and length 2.4 meters is bent to make an equilateral hexagon. Look here, let this be an equilateral hexagon, all sides are equal. Moment of inertia of this about an axis passing through the center of mass and perpendicular to the plane of the hexagon. Look here, suppose let us take the mass of the rod as capital M, length of the rod as capital L. Now, mass of each rod forming the side of the hexagon as small m, length of each side as L. We know mass of each side becomes m by 6 because hexagon has 6 sides. It is an equilateral hexagon. So, mass of each side becomes m by 6, length of each side becomes L by 6. Now, this distance, so moment of inertia about an axis passing through the center perpendicular to the plane becomes, by using parallel axis theorem, this distance, let us take it as r, moment of inertia of this rod about the axis passing through the center perpendicular to the plane is ml square by 12. So, for each side Ig is equal to ml square by 12, but I is equal to Ig plus mr square m. Height of an equilateral triangle is root 3 by 2L, because this forms an equilateral triangle. So, this distance becomes root 3 by 2L. So, root 3 by 2L whole square. There are 6 such rods. So, the moment of inertia of the hexagon so formed will be ml square by 12 plus m into root 3 by 4 L square, root 3 by 4 L square. Is it okay? Root 3 by 2 L into whole square. So, it is 6 ml square. Let us take ml square as a common factor outside, and the LCM is 12 here, 1 plus 3 3s are 9, 10 by 12, that becomes 5 by 6, this and this 6 gets cancelled. So, moment of inertia of the hexagon becomes ml square. Moment of inertia of the hexagon becomes ml square into 5. So, mass of each side becomes capital M by 6. Mass is given as 6 kg. So, that becomes 1 kg. And length of the rod is given as 2.4 meters. Each side length becomes L by 6, that is 2.4 by 6, that is 0.4. So, mass is 1 into 0.4 into 0.4 into 5. So, it is 0.16 into 5. This is 0.8. Okay. So, he gave it as something into 10 power minus 1. This becomes 8 into 10 power minus 1 kg meter square. So, the answer is 8. Okay. So, with that I stop the class for today. I will continue with some more problems in the next day. Okay. Thank you and bye-bye.